Hello everyone. Welcome to today's Leetcode problem, tuple with same product. Given an array nums of distinct positive integers, return the number of tuples A, B, C, D such that A, B is equals to C, D. Okay, where A, B, C, D are elements of nums. A not equals to B, not equals to C, not equals to D. Okay, cool. So what happens if like do how do this work? Like, let's uh, all elements of okay, so all elements of num are different, distinct, I guess, yeah. So we don't have similar numbers. And let's see, there are for this example, 2, 3, 4, 6, there are 8 valid tuples. Okay, so there's 2, 6, 3, 4, 2, 6, 4, 3. Okay, so the same but change of this 6 to change of same but change of a slight change from this, a slight change from. So, okay, I think if we find something that is, let's say, um, if we find something that is, uh, that makes a tuple, we can um, make 8 combinations of it. So that seems to be right, but let's see. For example, if you, yeah, if you see this one also, um, we'll find out that we find one combination and then it has 8 versions of it. And then we find another combination which is 20 and it has 8 versions of it. So that seems to work. Um, Now, let's, what is the basic thing that we can do here? I think first thing we can do is sort it out because that we don't want to find a number which um, is already found. So if we find 2, 6, 3, 4, we don't want to find 2, 6, 4, 3. So I think we should, for that, we should sort out because I generally know that in these problems, I would have to set A and I would have to set C, and then I'll have to find B and D. So that's how these problems generally work. So that's what I think also. Like if I find A to be this and I find B to C to be uh, this, then I can find these two numbers. Then I can start with C here, but that is not possible. So that would not work. But in this case, if we go A to be this, C to be A plus the index of A plus 2. So C starts on this. Then I search for B here, search for D here. Now C becomes this, search for B here, search for B here. And whatever answer I get, I can multiply that by 8. So that seems to be a logic that I think would work. Let's see. Um, for D, I think we can also binary search. So yeah, I will find A, B, and C. I'll set up A, I'll set up C, and then set up B, and then I can binary search for B. I think that's how we can write a very optimized solution for this. Um, are there anything else that I can do? am I doing? I was I looking at that? Oh, so couples same product. Cool. So let's start with this. Let's do sort. That is the idea. The idea is to sort it for nums dot begin, comma nums dot end. Okay, we have sorted it. Now we can for int I is equals to 0. Let's a is a is equals to 0 int n is equals to nums dot size. N minus, so a would be n minus 4. N is 4. N minus 4 is smaller than n minus 3, I guess. Not 3, 1. Yeah. So a is smaller than n minus 3, a plus plus. So this is where a would go, index of a. Okay. And what could be b? What could be c? So for int c is equals to a plus 2. Okay. So 0, 1, 2. Yep. C smaller than n minus 1 and minus 1, C plus plus. Okay. So we'll have to find B somewhere in between of A and C. So B would start from A plus 1 and at C plus 1, uh, C minus 1. So for int B is equals to A plus 1, B smaller than, what is B smaller than? Minus 1. C minus 1 or C? B smaller than C. So B smaller than 2. B, yeah. So B plus plus. So we have a B also. Now we can binary search for D, I think. So now these are integers. So we can also do binary search and if our answer is an integer. So let's keep that in mind, but right now let's not focus on that. Uh, right now find let's find D. Mm. Okay, so first let me find D with a linear search. Let's do a linear search for D. For D is equals to, then we can optimize it. C plus 1, D smaller than N, D plus plus. Because this will also be N cube only. It will not go more than N cube because uh like this operation, I don't know. It would probably go a little bit more. But yeah, it will. No, this both will be n square, so it will go quadratic. Um, so if n minus is equals to 0, uh, obviously this will have time complexity problems, but let's just see if our answer is correct. If A into B is equals to C into D, so plus plus. Cool. Let's see if this works. Okay, num, sorry, of A, nums of B, nums of C, nums of D, and closing bracket, closing bracket. Cool. Please C is equals to A plus 2, C smaller than. We have a wrong answer. So let's see where we are getting it wrong. So A0, which works. Let's try to debug this. Okay, yep, this works. C is 2, this works. B is 1, this also works. And D is 3. So nums of A into nums of C. I want nums of A into nums of C is equals to nums of B into nums of D. Yep, this is also wrong. So, oh, sorry, I did not want to open editorial. So nums of A into nums of C, 8. No. Do I want to check A into D is equals to, yeah, because we want the A into D is equals to B into C, because the greater number will always be, because of we sorted the great, and obviously this will give us a time limit, but let's just push it in and see. Yeah, clearly. Now for D, I think we can do a binary search. And if we get an integer only, then only we can do a binary search. If so, so what will be D? We are having A into D. So D is B into C by A. B into C by A into 1.0 is, let's take the C, 0 into C. We want, if this is integer, then only we will do this. Division by zero. Okay. Oh, nums. Nums. So this is slightly optimized, but obviously this will also miss the give us theory. But 32 to 35, we came a long way. Now, how can we get this better? We can do binary search for D. So the value for D will be this value. So uh, int dv is equals to this value. Okay. And if I take float of this, let's say float dv is equals to this value, yeah, into 1.0, and seed of dv, seed of dv is equals to dv. So if seed of dv is equals to dv, then we'll know that it's an integer value. And what else can we do? Now we can binary search for d. So uh, cpp binary, CRS, binary search, binary search, binary search, STL is how does this work? Binary search, okay, begin and value. If binary search nums dot begin plus c plus 1, or only c plus 1, comma nums dot end, comma int of dv. Yes, yes. So this reduces the time complexity a bit. Let's see if it passes. Ah, it's worse. Oh, it gives a wrong answer first. Binary search. Why does it give a long answer for this? Hmm. Let's go towards this version. Does this give a wrong answer for this also? Nope, it does not. What is the error that I am getting? Passes 35 cases and then gives a TLE. How much time have I taken? 21 minutes. That's okay. Binary search, binary search. Why isn't binary search working? Oh, so if I also do is equals to DV, it should work. And this gives us the wrong value. So DV is a problem. Why is DV a problem? Into 1.0. Let's check this out. Ah, I'm getting more answers than I should. Why is DV a problem? So let's do float. So let's instead of this, let's not do this. Obviously, this will be a problem. We have to know if it's an integer. Okay. I think we can do this. Speed of DV is equals to so int DV, then it should work. Yeah. It's over the answer. Why is it over the answer? I don't understand why it's over the answer. Someone at the chat has knows why it is going over. In the for D is equals to C plus 1, D smaller than D plus plus. If nums of D is equals to int of D, the answer plus plus. This is an integer, so we don't need this conversion. Why did I submit? But it's not wrong answer. On the 40 minutes mark, I'll look at the answer. I have 14 minutes to think about it. If today, what are you writing, bro? Today's slow hai kya? Are you covering the answer? I can't see anything there. Honest window. Oh, 1 lakh. I think there's this problem. 1 lakh. I'm sorry. There's this problem with Streamlabs. It kind of messes up sometimes. When I when I do much better on streams, then I'll figure out something that is better, pay for something. But right now, this is the free option that is easy to do. So currently, I'm facing this problem where I I have these three loops which calculate gives me A, C, and B. For D, I was earlier doing this. So if I go back a lot. So this was obviously time complexity wise a quadratic equation and PAL. It was giving me a TLE for 32. Okay. So next thing I did as an optimization was to basically calculate a DV and then, yeah, that's what I'm doing at the end. That is true. I am multiplying by it. That's not an issue. The issue is when I'm using this float value, so D comes out, like D value comes out to be nums of B into nums of C divided by nums of A into 1.0. And this 1.0 is first converting it into a float. And when I check for ceiling of this and in, I should figure out which if D value is an integer or not, because nums is an integer array. And then if it is an integer, try to find out D to use a hash. Why would I use a hash map? Uh, why would I use a hash? How would I use a hash map? That's a better question. Like, how would I use a hash map and why would I use that? Like, what is your rationale behind that? I Okay, hash map seems like a good problem. Like, I can how will I use a hash map? I was thinking of binary search. That was my plan. Like, if this was working correctly, I would have gone for binary search. But this does not work. This gives me an error. This gives me wrong answer. And I don't know why this gives me wrong answer. Okay, how would Ashna produce at 2n square? Let's see. Cube 2n square. I think I can go with n cube because of this, but uh, let's see. What can I store in a hash map? Uh, I don't know how I'll use a hash map to figure this out. Nums p oh man, nums store the frequencies. Frequencies of what? Frequencies of what value will I store? Every value happens to be one. So will I store A into C, which does not help me out, or nums of A by nums of C by nums of A somewhere, which probably helps me out in finding B and C, but not very sure. My current idea was to reduce this to a binary search, but for that, this should have had worked. I don't understand why I'm overestimating the answer in this way for this, like for the. But let's look at a hint. Let's say not all integer in this thing. This means that each time a product is formed, it must be formed by two unique integer. That is true. That is what I have also. Count the frequency of each product of two distinct numbers, then calculate the permutation. Count the frequency of each product of two distinct numbers. Oh, okay. Two distinct number. Okay. If I so 2 and 6 will give me 12. This will give me. Okay. Now 1 and 10, 2 and 5. Okay. Makes sense. That's much simpler. Like what we can do is we calculate the frequencies of all the products, and whichever happens to be more than two times. So there could be some products that will happen to be three times. Okay, so I think so. If there's a product that happens, yeah, I was going with a very straightforward approach with binary search. Um, and thank you for giving me hints without actually revealing the answer. I don't expect like anyone. I don't want anyone to reveal the answer. But yeah, I sometimes I like discussing the rationale because um in my journey I want to get good with the rationale of using something. I don't want just. I think that's the best way to learn this. Um, yeah, I'll have the frequencies of. Okay, once I have the frequencies, how will I know the permutation? Let's look at that. So 1 and 10. Are there three ways to form a number? Are there, if I do 1 and 10, uh, 20, 20 could be formed by, let's say 24. 24 could, because 24 has a lot of 24s can be formed by uh 1 into 24, then 2 in, yeah, there could be multiple ways, 2 into 12 and 3 into 8. So there could be multiple ways. So once I have a number, frequency for a number, how do I calculate how many tuples will be formed? Mm, Let's, how do I calculate how many tuples will be formed? How many tuples will be formed? How do I calculate? Oh, my granny just had a stroke. Uh, I'm sorry. What can we do? Right. Bye, no issues. I'm learning. Uh, uh, what can we do? Uh, it's counting frequencies, right? So, uh, and this goes to nums dot phi. Okay, and so for int I is equals to 0, I smaller than n, I plus plus. For int j is equals to I plus 1, j is smaller than n, j plus plus. Cool. Now, unordered map in comma int mp, mp of nums of I into nums of j plus plus. So we'll get the frequency of each multiplication happening. Now, uh, 26. Okay. If it happens 2 times, we get 8. Let's say there's 1 and 12 also. So let's say there's 1 and 12. So what will be our NP? I want to see that. Let's see. Variable. Marker. One common 12 is 12, 1. So 1, 2 is 2, 1. Then 1, 3 is 3, 1, 1, 4 is 4, 1, 1, 6 is 6, 1, 12, 1. Good. Now let's do 2, 3. 2, 3 is 6, 2. Um, 2, 4 is 8, 1. 2, 6 is 12, 2. 24, 1. Now 3, 3, 4 will be 12, 3. I wasn't laughing. I was just managing the situation. There are some problems where I get stuck up, so it's not a very big deal. Um, man, I forgot where I was. Let's do one thing. Let's do it much in an easier way. MP would be okay. So with this, I can get this will give me 8. How will 3 give me? So two of them will be giving me 8, another two will be giving me 8. So 3C2, 3C2. Uh, I have to choose any two amongst the three. So think of, uh, 3 factorial upon 2 factorial 3. Hmm. 3 factorial 3 factorial 3 factorial. Yep. So this will give me 24. So 3 factorial upon 2 factorial into upon 1 factorial. And this will give me 2 factorial upon 2 factorial, 1. This will give me 3. So if I have 4, um, then 4 factorial upon 2 factorial, okay, 6. Cool. I can do. Is there a better way for me to calculate this? NC2, NC2, 1C2. So, so for 2, we have 1. For 3, we have 3. For 4, we have 6. For 5, we'll have 5 by 3 factorial, 5 factorial by 3 factorial uh, into 2 factorial. So 5 into 4, 10, 3, 6, 10. I 1 plus 2 plus 3 plus 4. Cool. Uh, this is what I can see from the pattern. For 6, 6 factorial upon 4 factorial, 6 into 5. Okay, so basically the number minus 1, so 3 minus 2 by 2. 3 minus 1 by 2. 2. Okay, so n n into n minus 1 by 2. So for auto x of mp answer plus equals to n x dot second into x dot second minus 1 by 2. So return period. And answer is equals to 0. So, somewhere. So this is the n square answer. Can we improve it? I don't think we can improve it. So let's go to the solution, optimize proof for. Yep, this is what I was earlier doing. Not exactly, but A, B index and okay. Count product frequencies and a frequency patch now. Yep. Oh, okay, cool. I think that's it for this